Welcome back to our intermediate financial accounting class and to our last segment on time value of money. Now, we've talked all about time value. We've talked about why it's important, how it works, what interest expense is, and then we went through and did a bunch of different examples on time value, both from a business perspective with bonds and uneven cash flows, and then some very simple personal examples with investments and debts, etc. In this last segment, I want to walk through three practical examples, personal examples, but that will hopefully help cement the processes involved with time value. And we're going to start with this problem here. Let's assume that you've been offered an opportunity to make two different investments, and you can only afford one of them. So you have to decide which one is going to be best for you. You've decided that instead of using your interest rate and coming up with a present value, you want to figure out what rate of return these options provide to you. Now, this is a version of time value that we haven't done yet, but the equations allow us to substitute different things. So we can do this very easily with what we've already learned. So here are your two options. Option A, $10,000 today in exchange for $19.70 a year for the next 6 years. Option B, $10,000 today in exchange for $510 semi-annually for the next 15 years. So we're going to set up our equations, but before we can do that, we have to know what kind of a problem is this. Well, both of these have payments that are made over time, set amounts over time. So those are annuities. So they're both annuities. Next, is it present value or future value? Well, the fundamental question here is, am I willing to pay for this today? If I'm asking about what I'm willing to pay today, or if I'm willing to invest today, then that makes it a present value problem. Not because I'm looking for the present value. I have the present value. It's $10,000. That's what they want me to pay. But the question is about a payment right now. So even though I'm looking for an interest rate, it's still a present value problem because of what it is I'm looking for. So both of these are present value annuity problems. And with that, I can set up my equations. So let's take a look at option A. And the equation, again, is that the present value is equal to the payments times the present value of annuity factor at n periods at a given percentage. Now I know the present value because they're asking for $10,000 today. I know the payments for this first option were $19.70, and I know my n is 6 because they're going to pay for 6 periods. What I don't know is the interest rate. That's what I'm looking for. What interest rate would this setup give to me? So I can figure this out. If I take 10,000 divided by 1970, I get 5.07614, and I know that's got to be equal to my present value of an annuity factor, n of 6 at some percentage. And with that, I can figure out what this percentage is using a time value calculator. That's the easiest. If I don't have a time value calculator, I can still get it from my tables. So I'm going to go to my present value of an annuity table, and I'm going to find my n of 6. And I'm going to run across here until I find 5.07614. Ooh, I don't see it exactly, but 5.076 is pretty close to this value right here. So we're looking at about 5% as the interest rate on this particular investment. So my interest rate is 5%. That's option A. Option B can be set up the same way. So again, we're investing $10,000 today. The payments now are going to be $510. N is 30 because it's 15 years semi-annually, and we want to find the percentage. So let's see, 10,000 divided by 510 is 19.6078, and that's going to equal my present value of an annuity factor 30 at some percentage. And I can find that percentage same way I just did. So n of 30 is right down here, and I'm going to find that's 19.607. So 19.6, oh, I'm not seeing it quite, but it's got to be somewhere right around this 3%, somewhere probably a little below 3, right? Because this is 19.600, and it looks like 20.97, so it'd be probably 3.1-ish or something like that, because it comes out just about right here. So to be conservative, let's use 3%. And my first reaction to this would be, oh, great, I'll take option A. But option B is semi-annual, option A is annual. To get them into the same term so that I can really compare them, I either need to divide the 5% by 2, or the 3% I need to multiply by 2. So let's go ahead and do that. And even though at first blush it looks like this is a worse option, I'm better off paying $10,000 for this 510 because of the power of compounding. All right, let's take a look at another practical example. Let's assume that you've decided to invest in a home. You found the perfect place, it's $250,000. We can't afford a down payment at the moment, but the bank has decided that you're a good enough credit risk that as long as you'll pay 12% interest, they'll still loan you the money. So you decide to accept it. You're going to make your payments over 30 years, a regular mortgage. We want to know what will your payments be and how much are you actually going to pay for your house. So the first thing we have to decide is, number one, is it present value or future value? And number two, is it lump sum or annuity? The easiest of this is that it's an annuity. It's a mortgage. You're going to pay the same amount every month for 12 months a year for the next 30 years. So 360 identical payments, definitely an annuity. The other part of this is it present or future value? And the key here is that they're giving you $250,000 today for a series of payments in the future. You're not saving up, you're not trying to get the money for a down payment. They're giving you the money today. And since the big payment is made today, it's a present value problem. So this is, again, a present value of an annuity. Most of them are, let's be honest. We use future value sometimes, but it really is primarily present values that we deal with. So this is a present value of an annuity problem. So the present value of this annuity is going to equal the payments times the present value of an annuity factor, n at a given percentage. And the present value of the annuity is the $250,000 that they're giving you. I've got to find the payments. Oh, let's see, we got to figure out n. So n is 30 years times 12 months is 360 payments. And we know the interest rate is 12%, but it's 12% annually. So each month when I make a payment, it's 1%. Now, unfortunately, we can't just go to a normal table and get 360. There are websites out there where you can go out and type in your interest rate and your payments, and it will pop back either a factor or just give you a value. You can use a time value calculator. You can use the equations. You can use Excel. For now, I'm going to give you what the factor would be. But this is one of those where you'd have to play around with some other options. So for now, the factor here is 97.218. So 250,000 divided by 97.218 equals our payment, which comes out to 2572. Now, if you'd like to see one way to do this, let me go to Excel, and I'll show you the equation here. Let me zoom in so it's easier to see what I'm doing. So in Excel, we have a function called payment, PMT. Calculates the payment on the loan with given numbers. So let's put this in, and you can see right down here at the bottom, you can see that it has kind of hints for you of what you should be putting in. So the first is rate, that's my 1%. And the number of payments, number of periods, N per, is 360. The present value is the 250,000. There's no value in the future. This loan will be gone in the future. And then I hit end parenthesis. And it always comes out negative. For some reason they've set it up so it comes out negative. But you can see it comes out to virtually the same value that we got using a table. Let's go back then and answer the last question here. And the last question is something that's really eye-opening for most people. That is, if this is my payment, how much am I going to pay for this house? Well, you're going to pay the $2,572 360 times. So overall, you will pay $925,751 for your $250,000 home. Now when I do this, I usually have a student raise their hand and say, wait a minute, nobody pays 12% on a home loan. And you're right. Home loans right now are in the 3, 4, 5% range, at least when I'm making this video. But how much do you have as an interest rate on your credit card? Is it higher than 12%? 18%? 24%? 30%? They get pretty high. They're certainly higher in most cases than the 12 that we just used. So even though this may not be exactly accurate for a home, the idea, the principle, the concept that we pay so much more than we really took out, that's what I want you to grab onto with this example. It's one of the reasons why so many people say, hey, pay a little extra on your principal, get it paid down fast so that you don't get hit paying as much. If you can pay down the principal quickly, then you don't pay as much in interest. Because what we're really saying is $250,000 mortgage, you're paying almost $700,000 in interest, $675,000 in interest. Crazy, huh? May not be that way on your mortgage, but I bet it is on your credit card if you're not paying it off every month. Something to think about. And again, that's what we want with time value, is to make sure you're comfortable understanding what interest is really doing so that you can make some of those smarter decisions. Let's take a look at our last example. This is John Deere, and when John Deere retires, he wants to live on about $75,000 a year. He thinks he'll live for about 30 years after he retires. He's going to transfer his savings into an account that'll earn about 4% interest on the day he retires. All of his savings less that first $75,000, so he's got that for this first year. If he's going to retire in 30 years, we want to know how much is he going to have to save each month to meet his goal. Right now he's earning about 6% interest. This is a fun problem because it's really got two parts. We've got the part where we have to figure out how much money he needs, the first part, and then we have to figure out how much he's got to save each month to get to that piece. So this first problem up here, where we're calculating how much he needs, is a present value problem. It's a different kind of present value because he's going to take out the first payment at the beginning. So this is a present value of an annuity, but it's an annuity due because the first payment is coming out at the beginning, not at the end. The second part to this problem is saving. And we said saving is a keyword for future value. This is a future value of an annuity so that he can figure out how much he has to save in order to end up with the money that he needs. So let's start with the annuity. We need to know that first. So present value of an annuity due is equal to the payments times the present value of an annuity due factor in periods at a given percentage. Same basic setup as we've had before. We know that he wants $75,000 a year in payments. We know he thinks he's going to live for 30 years, so he needs 30 of these payments. And we also know that he's earning about 4% a year in his savings account. So with that, I can go to a present value of an annuity due table and get this factor. So let's switch. Present value of an annuity due, this is a different table. Notice it says it really big up at the top, beginning of period payments. We want 4% interest and 30 payment. 17.98371. And if we multiply that out, we get $1,348,778. So that's what he needs in his account on the day he retires. He needs this amount, and then he'll take out the 75 and put the rest of that 1,275,000-ish into his savings account and save for the rest of his life. So now we got to get him there. We've got to help him save this 1,348,000. So in this case, we've got a future value of an annuity, not an annuity due this time, just a regular annuity. We've got to make certain payments. We need the future value of an annuity factor in periods at a given percentage. So let's see, I know the future value of the annuity, I need it to be that much. So 1,348,778. I don't know what the payments are yet, but I know that he wants to save monthly for 30 years. That's $360. And I know he's making 6% annually divided by 12 to get to my monthly rate. So that's 0.5%. Now, we already know from looking at our tables before, 360 isn't on our tables. So the only way we're going to be able to solve this is by going to Excel. So let's go ahead and do that. And the good news is it's that same payment function. My rate is 0.5%, so 0.005. Payments are 360 again. Present value is 0. He's got nothing now. The future value is that 1,348,778 that we just calculated. And then we're going to hit in parentheses, and there's our payment. He needs to save $1,343 if he's going to have this retirement fund. So the payments will be $1,343. And if he can save this much and make 6%, he'll have this much when he retires. And if he takes out only 75% and is able to make the 4% interest, he'll have the $75,000 a year he wants for 30 years. You have to admit, this stuff is neat. It has so many applications: business applications, personal applications, savings applications, loan applications, and just giving us a sense of how interest really works. And it really comes down to that old saying about interest. Them what gets it, earns it. Them what don't, pays it. And now, hopefully, you're in that group, what gets it. And with that, let's get back to our normal series of lectures about financial accounting. See you then.